Good day, everyone. And once again, we are back together. We are looking at the subject of Surds. And today, we're going to be looking at rationalizing the denominator. All right, so if you haven't subscribed, please just make sure that you're part of the family. And of course, you are more than welcome to get in touch with us. Our email address is info@mlungisinkosi.co.za. Please note that we do have an upgrade class currently going, as well as maths and science classes for grade 10s to 12, just so that we can assist, and you can reach us on our email if you need those services. Right, now let's get right into it. Right, so first of all, when we talk about rationalizing the denominator, well, what are we actually trying to do? Right, so there are instances where we find that we've got surds in the denominator. So let me make an example. Suppose that we've got 3 divided by the square root of 2. Okay, so we find ourselves with a surd in the denominator, and so we want to remove that surd from the denominator, right? So what we do is we apply a process called rationalizing the denominator. So it means that we are making the denominator not to be in surd form. That's why we call it rationalizing. If you remember that a rational number in this case would be something that can be written as a over b in fraction form. It could be a whole number, and so on and so forth. Right, now what are we going to do first? Right, so whenever we rationalize, we multiply by what we call the conjugate. So you multiply by the conjugate. Okay, so the conjugate. All right, so in this case, what is a conjugate? Well, I'm going to apply the rules of surds in this case, and I'm going to actually help you to understand this. First of all, let's remind ourselves of a couple of rules, right? We said, well, if we've got the square root of a, or rather the nth root of a multiplied by, let's say, the nth root of b, we can actually write this as the nth root of a multiplied by b. All right, hopefully we all remember that. So that's part of the rules, right? So now, in this case, now if I've got 2 of the same kind of numbers in this case, now think about it. If I have the square root of 3 multiplied by the square root of 3, think about what happens in that case, right? So it means that you actually have the square root of 3 multiplied by 3, or you can actually write this as, well, this is the square root of 3 squared, and guess what? In this case, you would end up with just 3. Why is that? Because we said, well, when you write this in surd form, remember, or rather in exponential form, you'd have 2 over 2, which is equal to 1. So you end up with 3 to the exponent 1, which gives us 3. Now, what am I saying to you? That if we multiply 2 surds that are exactly the same, right? So if I have the nth root of c multiplied by the nth root of another c, right? I want you to note in this case, depending on, in fact, let me rather use the square root so that I don't, make a mess of it. So what do I end up with? I end up with c. So the square roots kind of cancel. So you can also look at this as saying this is the square root of c squared, right? So, and what happens? The square root cancels out with the surd, and in this case, you are just left with a c. So please keep that in mind, right? Now, the second thing is, now, let me take an example on this one, okay? But in this case, what we're going to do is, just using our FOIL method for multiplication, right? So we know, let's say, just for argument's sake, if we've got 3 plus the square root of 2, right? I want us to multiply this first. let's say 2 plus the square root of 2. Okay, right. So if we use our FOIL method, you guys remember this, that what we simply do is to multiply into this bracket and then multiply into that number. All right, so let's start with the first one. So 3 multiplied by root 2. In fact, let me just use different colors for that. Okay, let's start with 3 multiplied by 2. That will give me 6, right? And then let's say 3 multiplied by square root of 2. What do I get? I get plus 3 root of 2, right? And then for the next one, now I'm going to have this one at the bottom, right? 2 multiplied by root 2, that would give me 2 root 2. Okay, and in this case, let me just take another color, right? So root 2 multiplied by root 2. There we go. Now in this case, we've got two numbers that are exactly the same, or two roots that are exactly the same. So what does that give us? It will give us 2. Okay, so if I were to sum this up, what would this be? I take all the like terms, so 6 plus 2, right, would give me 8. 3 root 2 plus 2 root 2. Again, we did this when we're talking about addition of surds, right? So in this case, we've got exactly the same surd here, so we can actually add the numbers. So we've got 5 root 2. Okay, right. So I hope that you got that. And now I want us to quickly talk about now how to apply the issue of the conjugate. So if we've got a surd, right, in the denominator, now we're talking about rationalization, right? So if we've got a surd in the denominator, say for argument's sake, I said 3 over root 2. If we only have that surd, all we need to do is multiply, right? I want you to note the conjugate would be the same surd in this case. So I multiply both the bottom and the top by the same surd. What am I trying to do? I'm trying to remove the surd in the denominator, right? So what will this result in? This will be 3 multiplied by root 2. That's numerator to numerator. So that's 3 root 2 divided by. Now in the denominator, what do I have? I've got root 2 multiplied by root 2, and I'm sure that you remember this now. That's why I was showing you this. So what do we have? We've got, in this case, 2, right? So remember, root 2 multiplied by root 2 would give me 2. Okay, right. So at the end of the day, what will my answer be? It will be 3 root 2 over root 2. Note that we've removed the surd in the denominator, right? Now, when I've got more than one term in the denominator, right? So what happens when I've got more than one term in the denominator? Okay, so let's take an example. So let's just say we've got root 3 divided by 2 plus root 2. Okay, now note in this case, we've got more than one term in the denominator. Okay, I want to, before I get into it, right, I want to quickly remind you about the difference of two squares, right? So if I've got a plus b multiplied into a minus b, right, what does this result in? Okay, very quickly, I want to show you in this case. So you have a multiplied by a, that will give you a squared. You've got a multiplied by negative b, which would give you minus ab, okay? And then you've got a multiplied by b, which would give you plus ab. And finally, you would have b multiplied by b, and in this case, that would give us plus b squared. So what happens? Your brackets are the same, right? So what happens to the middle terms? They cancel each other. And what are we going to be left with? A squared minus b squared, Okay, so remember that is how we use the difference of two squares, right? So when you've got a denominator that has more than one term and one of those terms is a surd, in this case, what are we going to do? We multiply by the conjugate. And what is the conjugate? Well, when we've got more than one term, in this case, we've got 2 plus root 2, right? The conjugate will be the same bracket with a different sign. Okay, so the same things with a different sign. So in this case, that's 2 minus root 2. I'm only talking about the denominator. We'll continue to with that one once we're done. Right, so in this case, what happens? Remember, we have now created the difference of two squares, right? And obviously, as we go along, we will actually do this faster. So just to show you what happens, we've got 2 multiplied by 2, which is 4, right? And we've got 2 multiplied by negative root 2, which is negative 2 root 2, right? And again, we've got root 2 multiplied by 2, which would give us positive 2 root 2, right? And finally, you've got root 2 multiplied by root 2. In this case, that would give us 2. Okay, so now what happens? We note this cancels again. And what are we left with? 4 plus 2, that will give us 6. So in this case, what this simply means is that now when we've got something, okay, I may be running out of space. Let me just write it nicely. So if I've got root 3 divided by 2 plus root 2, to rationalize the denominator, what I do is I multiply by the conjugate. And what is the conjugate? The same thing as my denominator with a different sign. Okay? But remember what I do at the top, I do at the bottom. Why? Remember, that's the same thing I did there, right? Because it's the same as multiplying by 1, and therefore it means that our expression does not change. Okay? So I'm going to multiply by the same at the top and at the bottom. So in this case, it's going to be 2 minus root 2. Okay? Right, now, what am I going to do? At the top, I've got root 3 multiplied by 2, which will give me 2 root 3. Okay, and root 3 multiplied by root of 2, right? Please remember, we did say that this, you can write it as, root 3 multiplied, in fact, let me write it this way, root 3 multiplied by root of 2, in this case, divided by, now remember, at the bottom, what did we have? We ended up with 6, okay? So, okay, if you don't mind, I'm just going to remove all of this, all right? And in this case, what am I left with? Right, so I've got 2 root 3, okay? So I've got 2 root 3, and in this case, minus root 3 multiplied by root 2, in this case, that would give me the root of 6. You remember that multiplication rule that we can, because we've got the same root, we can actually multiply throughout. And this is divided by 6. And ladies and gents, you would leave it in that form. If it is possible to simplify it further, you would continue with that, right? Now, just quickly to take another example there. Let's say you've got 1 over, let's say 2 plus, actually let me change the sign, minus 3 root of 5, okay? So how would I rationalize this? Okay, all I simply do is multiply the numerator and the denominator by the conjugate. What is my conjugate? It's going to be 2 plus, right? I said it changes sign. We had a minus, now it's going to be 3 root of 5, okay? And what I do at the bottom, I do at the top. That's 2 plus 3 root of 5, right? So now, again, we would multiply at the numerator. Anything multiplied by 1 would be itself. So I've got 2 plus 3 root 5. But notice what happens at the denominator in this case, right? We said it is the difference of two squares. Now, there's no need for you to do that whole thing of, multiplying throughout, multiplying all your brackets throughout. All you simply do is take the squares of your first terms, right? So in this case, 2 times 2 would give me 4, right? And subtract, in this case, you've got 3 root of 5 multiplied by 3 root of 5. So 3 times 3, that would be 9. And root 5 multiplied by root 5 would give me 5. Okay, so in actual fact, you are looking at it as 3, the root of 5, all squared, right? So in this case, you'll have 9 multiplied by 5, okay? And that would, that should give us 9 multiplied by 5. So that would give us, my brain just froze me for a bit there. 3 root of 5, this is divided by, 9 times 5, that's 45, right? Yeah, that should be 45. Okay, so 4 minus 45 in this case, that would simply give us negative 41, right? Yeah, negative 41. And of course, if there is a way for you to, simplify this, of course you can. You're more than welcome to do so. And what I would like for us to do in the next couple of minutes is just look at some examples on how we can apply this going forward. I hope that it does make sense, ladies and gents. And of course, with examples, we can be able to reinforce what we've learned. All right, now let's get right into it. So our examples, they say rationalize the denominators of the following, the denominator rather of the following expressions. Right, let's start with the very first one, right? So they are telling us we've got 7 over root of 3. And what did we say? You multiply by the conjugate of the expression, and the conjugate will be exactly what we have there in the surd, right? So we've got root 3 over root 3, right? So in this case, what does that give us? We've got 7 times root 3, which is 7 root of 3. But remember, what did we say? We said that in this case, we are multiplying root 3 multiplied by root 3. That gives us 3, isn't it? So that will be divided by 3. And that will be our final answer. Okay? Now, going on to the next one. Okay, they said we've got 2 over 2 minus root 3. So let's do that. Okay, so there we go. Right, what did we say? We said when we rationalize rather the denominator, we're going to multiply by the conjugate of the expression, right? And what do? We create the difference of two squares, right? So in this case, I am going to do that. Okay, so remember, you take that as though it's in brackets. So that's going to be 2 plus, I'm already thinking of the answer, plus root 3. We said you do exactly the same thing, but the sign is different. And you do the same at the top, 2 plus the root of 3. What I do at the bottom, I will do at the top, so that in actual fact, I've just multiplied by 1, right? Okay, let's deal with the top. So that's 2 times 2. That will give me 4. Plus 2 times root 3. That will be 2 root 3. And at the bottom, what do I have? Well, we've got 2 times, I said to you, all we need to do is take those numbers and take the squares. So that will be 2 times 2, which is 4, right? The difference of two squares minus, okay, root 3 multiplied by root 3, that will give me 3. Okay, right, please keep that in mind, right? That all we've done. If you want to look at it in another way, you are just simply saying, okay, this is going to be that number squared minus that other number squared. Okay, that's how you look at it as, right? That would be your answer. So what do we have in our expression? We've got 4 plus 2 root 3 divided by, right, 2 squared is 4 minus 3 root 3 squared is 3, right? So 4 minus 3 would be equal to 1. Okay, so our answer would be 4 plus 2 root 3. Anything divided by 1 is in fact itself, right? So that would be our final answer. All right. I just want us to look at the next one. Okay, so for this next one, you've got square root 5 minus root 2. Okay. So for our third one, we've got root 5 minus root 2. Okay. Root of 2 divided by, okay, that looks really ugly. Okay, minus root 2 divided by root 5 plus root 2. All right, now let's have a look at it. So first of all, what are we going to do? Multiply by the conjugate. We've got surds at the denominator. So in this case, I'm going to multiply by square root of 5 minus square root of 2. Okay? Now, at the top, I'm going to have the same thing, square root of 5 plus, minus rather, the square root of 2. So remember, when you multiply by the conjugate, the same thing at the bottom, same thing at the top, so that we don't change the expression, right? So in this case, ladies and gents, all I am simply going to do, okay, now let's deal with the top. Now you need to be very careful at the top, because that is not the difference of two squares. It's two brackets that are exactly the same. So what do you have? You've got root 5 times root 5, which is 5, right? Now I want you to think about it. So you've got root 2 multiplied by root 5 in this case. So root 2 multiplied by root 5 will give us root 10. Remember the rules of surds. We said if we've got two numbers, root 5, or rather root 5 multiplied by root 2, in this case, what do we have? This is the same as saying root of 5 times 2, and so that will give us the square root of 10, isn't it? Okay, so we said, look, we would have minus the square root of 10, okay? And then when we take the other one now again, negative root 5 times root 2, okay? So again, that gives us minus root 10, okay? And finally, you've got negative root 2 times negative root 2, that gives us a positive, right? So that's plus 2 in that case. Remember, root 2 times root 2, that will give us 2. Okay, now let's try and simplify that, but let's look at the bottom. We said at the bottom, because we are rationalizing, so this is going to be root 5 plus times root 5, or you can look at it as just simply saying root 5 squared minus root 2 squared. You remember that, right? So what do? We've got 5, those are like terms, 5 and 2, so that would give us 7, okay? 5 plus 2 gives us 7, minus 2 root of 10, right? Divided by, in this case, root of 5 squared, that gives us 5, and minus root of 2 squared, that gives us 2, and ultimately our final answer is 7 minus 2, okay, let me write that nicely, 2 root 10 over 3, right? And what we've done is we've managed to rationalize the denominator, okay? Right, now I wanted just to take one final example, sometimes they do give us something that may not necessarily seem, that straightforward. I want to take this example. Suppose that they give us 10 divided by root of 45 minus root of 20. Now, ladies and gents, you must keep in mind that we are still going to do exactly the same thing, right? If they say to us, simplify, right? Of course, without the use of a calculator, right? So what are we going to do in this case, right? So I am going to try and write it in the most simplest form possible, right? If you want to, you can actually just try to simplify this as much as you possibly can, right? So again, that's going to be 10 divided by, if I think of root 45, do you still remember? That would be 9 multiplied by 5, isn't it? So that's 9 times 5, okay? Minus, if you think about 20, that's going to be 4 times 5, okay? You still remember that, right? So this is going to be 10 over, now square root of 9, in this case is 3, root of 5, okay? Minus 2 root of 5. Do you see that if you looked at it at face value, it seemed like there's a lot that you needed to do, right? But when you actually start working through it and simplifying things, do you see that we only have one, what do they call it? 1/3, right? So this would be 3 root 5 minus 2 root 5. That would simply give me the root of 5. And all I simply do, I just rationalize. In this case, that's going to be square root 5 divided by square root 5. And what do I have? I've got 10 multiplied by root of 5. That's 10 root of 5 divided by square root 5 multiplied by square root 5. That would give me 5, right? So 5 into itself once and into 10 twice. So my final answer would simply be 2 root 5. I hope that makes sense, ladies and gents, that you've been able to get that. Now, of course, as per usual, I'm going to give you your own exercise that you're going to try, right? And please just give us the answer as part of your, comments. All right, tell me what you get as your final answer. Okay, right. So if we've got root of 3 minus root of 2 divided by root of 3 plus root of 2. Okay, give me that as your final answer in your comment section. All right, and I will see you again next time. I think that's where we'll leave the lesson. And please don't forget to subscribe and to like and share and tell as many people that your favorite uncle is always doing the most. Otherwise, I'll see you guys again next time. Shap shap.